Because if you look at number 11, you have secant over cosine minus 1. And the other one you have secant over cosine minus secant times cosine. So if I'm looking at number 12, isn't secant times cosine two inverses multiplying against each other? When you multiply inverses together, what do you get? 1. So these are the same problem. Okay? No, it doesn't equal 0. I'm going to sit there and notice the fact that I've got some trig function minus a 1, which means it's probably an identity. So I'm going to bring the cosine up. When I bring the cosine up, I wind up with secant squared minus 1, which is, you're done.
Okay, I got that, but I did a lot more work.
And that's fine.
Is it okay to bring the secant down, work it out, then bring it back
Sure.
up? Okay.
You work it out, and then you get common denominators, and you get the same result. Okay? You will. There are many different ways to do this. Some ways are quicker and easier than others. It just depends on where you start. If you hit a brick wall, erase it and start over. It happened to me 6th hour. I was doing a number 55 on the sheet with those guys, and I kept getting stuck in the same spot. I did wrong. Then they left, and I sat down for a second, and I looked at it and went, oh, I'm an idiot. And I tried something different, and it worked out in like 3 steps. It happens. These are meant to make you think. It takes time. You did it in 1 day. Most people by the end of today have gotten a lot better at it. Yes, ma'am.
How do you know if it's a brick wall or whether it's just the answer? Like,
Well, if you get to the point where you don't know what to do next, or you think it's simple, you learn the field. Okay, you learn it. All right? Attaboy! Exactly. And you'll have to trust me. You start to see better. Okay. As you get into the ones that have a singular denominator, like in 13. Couple of things that you can do here. Whenever I see a singular term in the denominator versus 2 parts in the numerator, I usually split it. I do that too. I usually split it into 2 fractions because I might be able to simplify each fraction individually. So I have 1 over tangent squared.
Where do you get the R for split?
I mumbled. What's 1 over tangent squared? So what's cotangent squared plus 1? You're 5. It's that detention. Too soon?
Yeah, I didn't do it like that.
you should get detention.
I'm sure it's like a funny what? What? I had a sleepless. It was a good time. Anyways, they're actually serious about that.
Okay.
Apparently, you get along with it.
When you got into ones with the 50 degrees, 350 degrees, we talked about that. That just means as long as it was saying the properties still hold true. So don't worry about that. Are there any others in that first 18 you want to double check before I go to the last tower? Invalid. If you split it apart, got common denominators, and did all that extra work, and wrote sines and cosines, you just did a lot longer to go through, and it's fine. It's okay. If you start to pick on these little tricks, little things throughout, you'll be all right. It's no big deal. There's no set amount of steps you have to do it, just like you guys do with proofs. You don't have to do it in 8 steps. You can do it in 4, depending upon if you get the right things written out. That's all it is. Yes, ma'am.
So for 13, instead of cosecant squared, I put 1 over sine squared. Do I have to put that?
I would prefer that because 1 over sine squared is something
Yeah.
else. It's just a little bit cleaner than when you get rid of fractions.
But if I accidentally left it that would I get wrong?
Try not to.
I mean, I'm gonna fix it, but if I accidentally do it,
You might get frowny face.
is that like, am I gonna lose
7,000 points off.
I'm gonna get that anyway.
That's a big. Oh, speaking of which, your test is on Friday. We'll have the test on Friday, all non-calculator stuff. We'll talk a little bit more about what it'll look like on like tomorrow and stuff. Correct, just writing it. 1 plus tangent squared is what? 1 plus cotangent squared is? Hi.
Hi.
How are you? I'm fantastic. He can't go. He's very busy.
No, he doesn't.
Cotangent squared is,
You fell asleep in French today.
all right? Now, here's what I want to do. Notice, secant squared and cosecant squared are both inverse functions. Do you agree? So secant squared is 1 over cosine. 1 over cosecant squared is sine. So I wind up with sine squared over cosine squared, otherwise known as?
I was right the first time. Shoot.
Trust yourself. Trust it. Okay?
Wait, so you just left?
Yes, sir. What I did here is, remember, I'm rewriting this in terms of sines and cosines. Secant is 1 over cosine. When cosecant is in the denominator, it's the same as sine squared in the numerator. Okay? Second group. What's wrong, Molly?
No, I'm just.
You have the look of disgust more so than normal.
Probably gets to it when it's just like,
Verifies. What's nice about the verify, at least you know what it should look like when you're done. Hopefully. So as I'm looking at the first one, I have sine squared times the quantity 1 plus cotangent squared. There are multiple ways to start this. You could distribute, rewrite in terms of sines and cosines, or recognize that 1 plus cotangent squared is cosecant squared. So you wind up with sine squared times cosecant squared. And aren't those two inverses of one another? And what happens when you multiply inverses? And you get 1. Okay. What's up, Al? How are you? It's great. We're verifying trig identities. They love it.
Shut up.
Do you guys actually love it?
No.
Yes.
Oh, come on, it's kind of fun.
No, it's not.
It screwed me over, man.
hey,
It's easy.
what are your emails?
Huh?
4 days.
4 days. Yes, 4 days. 4 days? 4 days. 4 days. Yes.
Wait, how many days?
Oh, it's the Mr. DHS.
Yeah, it's gonna be exciting. Huh?
I didn't hear you.
It was 4. Yes. Thank you.
what?
How's he doing?
Who?
Tomas. Yeah. He's got a little bit of
Stops
energy.
talking.
I know, right? He's so loud.
You want to be recording?
No, I'm good. Yeah, I'm pretty sure if I did want to do it wrong, and I don't want to look like a fool.
It's okay. I do it wrong half the time.
Yeah, I know, but that's you. They expect it.
That's why I'm saying, but they have more expectations. See you, Dave. All right.
Is that how math teachers talk to each other?
Usually, yeah. There's usually a little bit more profanity, but that's not usual.
They just verified.
Second one.
Stuff.
Sine squared. Then we have a cosecant squared plus a secant squared.
Oh, wait, never mind.
Now, in this one, you have the distributive property coming in again. But what I'm going to do is rewrite the interior parts in the parentheses in terms of sines and cosines. Okay? So I wind up with sine squared times 1 over sine squared plus 1 over cosine squared. You okay with that? Nice one. Nice one. Now distribute. When you distribute, you get sine squared over sine squared, which is 1. And then sine squared over cosine squared is? And what's 1
Like you
plus?
said, tan squared.
Tangent squared.
Where does that come from? Secant squared.
And it is.
I mean,
Can I believe how easy this is?
Isn't it silly? It's the whole idea of stopping and thinking, going, wait, okay, what can I do? All right. A lot of times it's rewriting in terms of sines and cosines, going through a couple of those Pythagorean identities and trying it. 1 plus 2 plus 2 plus 1 is 1. 33 and 34 is where most of you guys really, really not liked math.
Yes.
They're both very similar in how they work. I don't know if you noticed that on these sheets on the problems I was giving you guys. They were kind of the same problem, like one after another, and then they go to a different style. Very subtle differences. Well, the first one, if you're looking at it, you got cosine squared minus sine squared. You want it to equal 1 minus 2 times the sine squared. That means that the cosine squared went away. Where'd it go? I don't know. So
Gonna find out.
we're going to find out. So that means you probably want to rewrite cosine squared in terms of sine squared. So cosine squared is equal to what?
1 minus sine squared.
1 minus sine squared. So you rewrite that as 1 minus sine squared minus sine squared 1 minus 2 sine squared.
Wow.
That's what I know, right?
Yeah, well, that's all that is. You don't need to memorize. All you have to know, in all honesty, are those two. The rest of them you know. Sine squared plus cosine squared is the Pythagorean theorem. It's y over x. You know that. Y squared plus x. You know that, right? Y, because if you look at your unit circle, y squared over x squared is your radius. There it is. Your radius unit circle is 1. The only two that would technically be different is knowing that those guys go with each other. That's all it is. Knowing that those two go with each other. The rest of it, the inverses, you know all that. You know that cotangent is cosine over sine. You know tangent is sine over cosine. You know how those work themselves through. It's just a matter of placing them. Once you get those literally, the manipulation of it by solving for the other parts, that's easy. Adding, subtracting, no big deal. All right?
So do we rewrite sine to cosine?
Yep. When you do that in this one, you just got to be careful. Because you have parentheses with the subtraction. So you have 1 minus cosine squared. So you have to be careful to distribute out the negative. So you have cosine squared minus 1 plus cosine squared. And that's where you get your 2 cosine squared and a 1 minus it, and you're done. I tried. It was cold-ish or out today, so I was thinking of partridge in a pear tree. Okay?
March.
Lousy smudge weather. Excuse me. It's a Simpsons reference. All right. Let's do a couple more of these. Let's show you a couple other tricks. We're just gonna add on some problems. Yeah, you can put them in your homework, put them in your notes, whatever. Because we're gonna do more of these today. This thing's annoying.
Why did it read those lines?
Yeah, why does
I
it
don't know.
copy two lines?
I don't know. Your guess is as good as mine. I wanted to kick this thing today.
Today.
More
What
than
about
once.
every other day?
I want to look at number 19. So I have sine times cosine over 1 minus sine squared. Once again, I want you to recognize the fact that your numerator, or excuse me, your denominator has 2 parts to it, which means I can't split it up into 2 separate fractions. But notice that it has a squared term in that. Since it has a squared term, that means I don't need to worry about doing that conjugate jump. Yeah, so what's 1 minus sine squared? So you wind up with sine over cosine squared.
Sine over cosine equals 10.
And you go to the next problem. It's picking up on those little subtle differences within the problems that allow you to do those shortcuts, the short work. Okay? If I look at 20, it's kind of similar in that the idea. Your numerator has the 1 minus a cosine squared, whereas the denominator is just 2 things being multiplied together. Since I have 1 minus something squared, I want to automatically think, is it an identity? It is. So So what's 1 minus cosine squared?
Sine squared.
So your numerator becomes sine squared. And once again, what happens? Things happen, and you wind up with a tangent. It's those quick, all right, what do I have in front of me? What can I try to do? All right, this little subtle things you start to notice. When I get into something like 21, though, it's almost like, I don't want to say that it's all bets are off, but you know, notice how we have a secant, sine, and a tangent. Rewrite everything you can in terms of sines and cosines. Okay? Rewrite everything in terms of sines and cosines. Not shortcutting anything right here, just so you guys can see what it looks like when I do that.
Okay, so it's 1 minus sine squared over cosine?
Correct. What happens here is that your numerator, so hold on a second. Order of operations tells me to take care of multiplication before I take care of subtraction. Do you agree? Yes. So that secondary fraction, to simplify that out, you wind up with sine squared over cosine. Do you agree on that?
Yes.
Now, do you have a common denominator?
Yes.
Yeah. So you just put the numerator together, and lo and behold, it looks exactly like a problem we did a second ago. Because what's 1 minus sine squared?
Cosine squared.
So cosine squared over cosine is? It's not as scary as it looks, is it? Is some of the cost lifting
Yes.
smidge? 10 feet of visibility instead of 6, that's better.
The wind.
Well, is there really much wind when it's foggy?
Yeah.
It's like a blizzard. Yep.
Yeah, you're right.
I'm not immune.
It's like driving in the fog
And
with your
your
eyes
eyes
on.
You would know that.
All right, take a look at this one. 1 minus sine squared over 1 minus sine, all minus 1.
We just do the
It's
thing.
cosine squared over what? Over 1 minus sine.
All right, yeah, that's one way of doing it, but take a look at your first fraction. Isn't the numerator a difference of squares? Is 1 a perfect square?
Yeah.
Is sine squared a perfect square?
Yeah.
Is that a subtraction sign?
Yeah.
So what can I break that into as far as two terms?
Plus minus.
So I will go 1 plus sine, 1 minus sine, all over 1 minus sine, minus 1. What happens?
We get sine.
You get 1 plus sine minus 1, therefore your answer is?
It makes so much sense.
And then like when you try it on your homework, it's like, what even is this? It's like,
Yeah, I get that a lot in this section. Oh, it's so easy, 'cause you can do them. Well, yeah. But I also screw up too. That's 6, 7. I couldn't do this problem to save my life. But then all of a sudden they all left and I got it done in like a minute.
I bet we don't have really good scores on the test to like help us.
If you took it for me.
Yeah. Maybe we should.
You're trusting my my answer key. I never make mistakes.
That would make less sense.
All right, let me show you another little set that happens quite often. What happens quite often with some of these trig problems, or these verifying style problems, remember, when you have to verify, they're going to give you the answer in the end. They're going to say, hey, this is what the answer's going to look like. Make it look like this. Make it so. Well, one of the things that it'll do is that they're going to give you addition to start with, and it's got to look like multiplication when you end. That means somewhere along the line, you had to create a common denominator. You had to create a singular fraction. Okay? So when I start out with something like this, like 35, I'm going to rewrite cotangent and tangent as sines and cosines. Okay? So I get cosine over sine plus sine over cosine. And I'm going to have to come up with some common denominators, which means I want to remind you how you get common denominators. So if you had 1/3 plus 3/4, what would you do? You would make the denominator 12 because you just multiply them together. So the fraction on the right had a 3, so it had to be multiplied by. So you have 4 times 1 here. You okay? And then on the other side, you have to multiply it by.
This is the hardest thing we've done all year. Oh, this is all space.
I agree with Lily.
Oh,
We are doing this stuff.
Just have to square
the real numbers.
Now watch.
No.
To get the common denominator here, what's it going to be?
Cosine squared.
Sine times cosine. Now, the fraction on the left needed to be multiplied by what? So what's cosine times cosine?
Cosine squared.
Fraction on the right needed to be multiplied by?
Sine.
So you get, what's cosine squared plus sine squared? And 1 over sine times cosine is? Cosecant secant. What happens, and this is the idea here, when you see, this is kind of like one of those red flag things. When you see that you have addition to start, multiplying at the end, you had to have some sort of common denominator somewhere along the line. Yes, sir?
I missed where you got the cosine squared and the sine squared.
Remember, what happened here is the common denominator winds up being sine and cosine.
Yeah.
So this fraction you had to multiply by cosine. This one you had to multiply by sine. The same idea where I had 3 and a 4. This one needed to be multiplied by 4. This one had to be multiplied by 3.
So you times them by the opposite.
Yes, sir. That's how that works. It's a nice little trick that happens quite often. Okay.
Okay, so what was the answer now?
Oh, this works out to be cosecant secant. That's all. I see it right.
Oh, it's
It's
because
an
we
inverse.
split. Yeah, because we split it up.
This one. Okay. What's the other one like that? Secant squared plus cosecant squared. I want it to equal secant squared times cosecant squared. First thing I'm going to do, I always think that it's easier to work with sines and cosines. Plus the fact that I noticed that I have addition going to multiplication, that meant I had to have some sort of fraction to get a common denominator. Okay. So secant squared is the same as, so I have 1 over cosine squared. It's 1 over sine squared. What's going to be your common denominator? So your common denominator is going to be cosine squared, sine squared. Fraction on the left needed. Fraction on the right needed. And what's cosine squared plus sine squared? 1 again. And isn't that your inverse? And you're done. It's that, yes ma'am?
Is the numerator always going to equal 1?
No, it's just dumb luck. with these two, because it could be proven something else. It just so happened in this case it worked out. I know that it happens before that.
Okay.
All right. Let's see. Yes, sir. Oh, yeah, we're going to give you the more pain. I joke, it's not that bad. These are, the ones I'm doing today are harder than what you have to do tonight.
Because we're gonna give him more cheater punches him in the face.
All right.
Oh, I'm not gonna be here for your class tomorrow.
All right.
Sad.
In this one, when you have your denominator, I want you to notice that there's two parts in the denominator, and neither of them are squared. See you later, sir. Notice how neither one of them are squared? That means I can't use a Pythagorean identity, and I'm not going to split up the fraction, which means I'm going to make a Pythagorean identity. Not squaring it. This is where you have to multiply by the conjugate. So I'm going to multiply by the conjugate to create that difference of squares, to create one of my identities. So I have sine over 1 plus cosine. What's the conjugate now of 1 plus cosine? Okay. My denominator becomes now 1 minus cosine squared. And 1 minus cosine squared equals? Sine squared. My numerator is nothing more than sine times 1 minus cosine. Knowing that my denominator is eventually going to wind up being sine squared, should I distribute here? Nope. So I'm just going to move it over. And, what do? Game of war. And I wind up with 1 minus cosine over sine. Now, do I have a singular piece in my denominator that can split into two fractions? That's how you set that up. Okay. So you get 1 over sine minus cosine over sine, which is cosecant minus cotan. That's the trick to get yourself away from the two parts you can't use to make it into one you can.
So is that kind of like when you're trying to get a root out of the denominator?
Yeah, same idea. Multiplying by the, when you multiply like by, if you have 1 plus root 3 in the denominator, you multiply top and bottom by 1 minus root 3. It's the same idea, like we did with the I values. This is how you can multiply by a factor of 1 and not change something.
This is only in verify problems though, right?
I'm sorry, 1 second. What's that?
We'll only have to use the conjugate in verify problems, right? Or will we have to use
I don't think they show up that often in the simplify. It's a trick that you can do,
Okay.
because sometimes it helps you get out of a bad spot. Okay. Sorry, Zach, what's that?
Are we doing any more sections, or is this,
This is pretty much about it. There will be a problem here, and I don't know if I'll get to it today. I'll definitely get to it tomorrow. That you can use a simplified technique to solve an equation. Because that's the only thing we didn't do in 14.4, because there's a couple problems of that. And once you guys see how that works, and it's usually within a Pythagorean identity of just replacing a sine squared and a cosine squared, how it falls into place. It is relatively easy now that you start to see these a little bit more. That's really like the last little bit. And I'm trying to remember if I have it on this sheet or the one you're doing tonight that the problem comes up. Yeah. I got more problems than you can shake a stick at with these.
Do we have to worry about the root measures? Or
No.
Do we just ignore them? Like,
Yes. With verify and simplify, you know on the front sheet how they had like a 50 degree and 50
Yeah.
degree? As long as they're the same, who cares?
Alright.
Do I even put an X in any of these?
No.
Because it's a waste of time. What's the other one I wanted to do?
So after this, are you gonna start on that?
We'll get there eventually.
I'll take it.
58 looks
You don't
unsolvable.
want to take it, just put it.
Yeah, we don't worry about absolute value with roots and stuff like that. That's just kind of really not fun. Oh, what was the problem? Forgot. Okay.
It's a baby
On number 50, we have a cosecant over a cosecant minus 1 plus a cosecant over a cosecant plus 1. And it has to equal 2 secant squared.
Is this like a mega difference of squares thing?
Pretty much. Because in this case, there's really not much I can do. I can't simplify either one of those. I don't want to kill any puppies. That's not nice. But I can get a common denominator. My common denominator in this case would be just multiplying those two denominators together.
So is it cosecant squared minus 1?
It will be, yeah. But I'm just going to write it out in long form first, just so we can see that. Okay. What's wrong?
I'm just thinking about like how you can apply this to like real world. And why would they not just give you the 2 secant squared if you could like, you know what I mean?
Well, it's also like, how do you fit? Have you ever done the backpack problem? No. The backpack problem is, I have to look it up. It's a problem-solving technique where you have an order of importance of value of weight versus monetary value, that you only are allowed to have so much weight in the backpack versus so much monetary value in the backpack to survive. It's a thinking problem.
You just bring a really big backpack.
You bring a really big backpack. Yes, you can do that, but it's just a problem-solving thing. It's really all this is. And the better you guys get at problem-solving stuff, the better everything else gets. That's really all these exercises are. I know 98% of you already go with math.
But it's just things to think about.
Yeah. So fraction on the left needs a cosecant plus 1. Fraction on the right needs the cosecant minus 1. We okay with that?
Yep.
All right. Now, what happens here is that you guys, the numerator, you wind up with cosecant squared plus cosecant squared minus cosecant.
So it's 2 cosecant squared.
You okay on that?
Yeah. Okay, I got you.
Those drop, right?
Yeah.
Yes, no, maybe so. Okay. I ran out of space there, so I'm just going to bring that down. So this becomes 2 cosecant squared. That's my numerator. We okay on that? The denominator here was cosecant squared minus 1. What's cosecant squared minus 1? Cotangent. So right now I have 2 cosecant squared over cotangent squared. That's where I'm at. All that junk wound up to be that. Let's rewrite it in terms of sines and cosines. The 2 value is just a constant out there. It's just there. Cosecant squared is 1 over sine squared. Okay? And now this is times 1 over cotangent squared. 1 over cotangent squared is tangent squared, which is sine squared over cosine squared. So I'm just going to do that real quick.
Sine squared is cancelled. And you get 2 over cosine squared.
And you get 2 over cosine squared, which is 2 secant squared and a partridge. Yeah, it is. You gotta laugh at it because it's absurd. Right.
I never thought that I would actually ever do math that only had 2 numbers in it. Like I always joked about it, like, oh, who decided to put the alphabet in here? And now it's all letters.
It's the same idea as geometry proofs. It's just
Not the same idea, just like easier.
Proofs are like the only things to
this way you don't have to write. Yeah, you don't have to. There's a little less work that you have to do. I mean, fill out your agenda. Yeah, that's
Look at how
She assigned me stuff.
So I'm still.
Look, we're gonna pass it. Alright. Now,
I was wearing Kool-Aid.
what I want you guys to do is the exactions over your shoulder, Mike. They're passing forward. I felt like being different. What I want you to do. No, they do this too, but this is, believe it or not, there are things on the internet that you can search for, like worksheets. This is a worksheet I found on the internet.
That's some weird freak out stuff.
Sounds like
I'm getting harder. You really want to?
So I want you to do the evens, the 2 through 36. These are a little bit easier, I won't say a lot, but a little bit easier than the ones I just did in class.
This time the evens are on the same side on either side of the face. That's good.
Except for 16 on the back. Just this 2 through 36 side, okay? 2 through 36 right here. That little chunk right there. You should be able to get through most of these without a hassle.
Just the evens? I thought you meant like to all of them through 36, and I'm like, oh, how kind, 34 problems. You're so nice.
35.
You're missing the point.
so the right column.
Okay. I will say one thing on number 16. Number 16 is the only problem that I've seen in all of these that you have to go right to left. So when you get to 16, just go right to left.
16 on the back.
You're not doing the 16 on the back because I said you're doing these on the front. So whenever you see these problems, you're always going left to right. On the test and all that, it'll still be set up that I'm asking you guys to go from left to right. It just so happened I didn't type this myself. That's why
Like,
it's
use
looks
the
like.
answer they get when you start with?
What's that?
You mean use the answer you get when you start with?
Yeah. Just go right to left. That's all it is. It's the only time. What's up?
No, you're just.
I'm sorry,
saying
Mr.
how
Murphy.
long
My
that
brain is
is.
just.
I sense your sarcasm, Val.
It's like,
Wow. This is why we get along. Because I never got swept in high school. I had my driver's privileges taken away for acting like an idiot in the parking lot. So here you go.
Was that in high school or as a teacher?